So guys, I wake up late today, so I have a little bit of fever. That's why. So today they discussed about unsupervised learning, how clustering works, and generative AI. He thought in a very simple way. He didn't go to the depth of the mathematics, but it was decent to give overview how generative AI works. In other words, they call it GANs. Fine. So I'm waiting for the second presentation. It will start on this minutes.
Hello and welcome to the second session of Unsupervised Learning. I am Nilotpal and I'll be the instructor for this session. I am an applied scientist at the Retail Business Services team here at Amazon. So in this session, we'll mainly look at representation learning. Representation learning deals with learning good representations from unlabeled data. So whenever we have image, for instance, or text or graph or speech, etc., we want to turn them into vectors, or in other words, we want to learn meaningful representations of these images and text. And after we learn these representations, we can then use them for various applications like clustering or retrieval or like training any other downstream supervised models. Now, many of these useful representation learning methods are in fact unsupervised in nature, or like they are self-supervised, which is also considered as a subtype of unsupervised learning. And so it means that that unsupervised representation learning doesn't use any explicit supervision like human level data. Rather, these meanings are learned by exploring the intrinsic distribution or structure of the data set. Like, for example, distribution of words in documents. And talking about its usefulness, most of our data are unlabeled, like most of the images in the internet. And also in some cases, like in medical domain, labeled data is very hard to find, but there is a lot of unlabeled raw data. So unsupervised representation learning is a powerful way to leverage this enormous amount of unlabeled data that we have available. And so we look at
posted questions immediately. Just wait for a couple of seconds before it shows up. Okay, so the next is throw some light on the BERT model. I didn't understand the masking thing. So the way BERT is pre-trained is with a method called self-supervised learning. Here what we do is given the entire text that we are using as our training sample, and with any lack of labels, what we do is we mask the words in between the sentences, and given the rest of the sentence, we ask the model to predict that particular word. Right? In that way, it learns to predict words based on its context without any additional labels. Right? I hope that clears what masking does at BERT.
Yeah, thanks, Arindam. I think the next question is a more generic question about what is unsupervised learning. So this lecture is all about unsupervised learning, right? Why do we need it? Is usually unsupervised learning is a technique which is a counterpart to supervised learning. It's the main applicability of it comes when your data is not labeled. You have an input distribution which defines a particular problem statement or underlying distribution, and is there anything you can do to extract patterns from it, right, which could be later useful? So unsupervised learning takes this as in its objective, right? And how do we get patterns out of it? There are multiple ways of getting, right? Either you can group the data into different cohorts, which is clustering, right? Either you can use the data to learn some meaningful representations, right? Depending on the input modality. For images, let's say you want to image or text, right? These are raw data, and you want to convert them into some sort of numerical representations, which are more semantically meaningful, as well as it can have some clustering and cohorts within the representation learning, right? So these are a few things wherein you can directly start learning as a first thing, right, with just the input data without any labels in it. And then once we have some sort of middle ground or some learned representations or embeddings, right, you can still go ahead with your fine-tuning task on the supervised or the data set which you have some labels on, right? So either it could be used for an exploratory analysis like clustering and trying to figure out what sort of cohorts the customers belong to or the specific data belongs to, or also to get into a representation learning part wherein it is used to get raw information or extract patterns from the input data, and then later used for more specific downstream tasks such as text-related NLP fine-tuning or image-based classification or segmentation fine-tuning, right? So these are some of the major concepts I think we have read part of this lecture, as well as the techniques of unsupervised learning.
And I think that in some sense answered the next question as well, which is about difference between supervised and unsupervised algorithms.
That's right. So I think the question asks about what is the main difference and real-time difference. Not sure what is that. Maybe is it about applicability in inference or?
Yeah, I think by real-time they might mean the latency and stuff, but in which case I don't think there is any such significant difference based on just supervised and unsupervised. If you meant something else, Siva Subramaniam, please feel free to clarify the question again. Okay, next is how LLMs are fine-tuned in creating custom chatbot with reference to how Amazon does it. Well, how Amazon does it is, well, it's more or less same the way everyone does it. So LLMs are usually pre-trained on language models, so it has a lot of world knowledge about languages, but they are not always very suitable for chats. So for that, we use some kind of fine-tuning called RLHF, that is reinforcement learning with human feedback. There we give it the human preferences of how we want the chatbot to answer questions, respond to some particular scenarios, whether it is making sure that they don't, use inappropriate language, or making sure that they answer in a tone that is required by the question. Those things are done using some form of reinforcement learning with or without human feedback. I hope that answers the question.
I think next we have a question from Ayushman on how or when to decide to use general artificial neural networks and RNNs, right? So these are two specific architectures or neural networks suited basis the input data. So you can use a normal neural network for, let's say, tabular data wherein your features are defined, right? There is no temporal structure to it. Or any other information wherein you have features related to a particular, let's say, a customer or an order, right? Some sort of feature vector which you normally give to any non deep learning based methods, right? You can use neural networks for that, which is a fully connected network. RNN in specific is to handle temporal data, right? Let's say you have a time series data which has a temporal relationship between the current token or the current point in time with respect to the previous as well as the future time periods, right? So in such cases, you can use RNNs and LSTMs. And recently, we also have transformer-based models, right? Wherein the need here is to, whenever you want to predict something at a particular time step or a token, you need to also have the context of what happened before and what happened later. While in normal artificial neural networks, you don't have that requirement, right? Given a set of features, you just want to predict a target vector, right? So this usually defines the criteria to use these two models.
Okay. So the next question is basically how do we choose the hyperparameters for an ML algorithm? Well, the answer to that question is that we need to have some data that we're training our ML algorithms on, right? So what we do is we keep a part of that data aside, and then once we train on rest of the data, we use this data to optimize the hyperparameters. So we take various combinations of those hyperparameters, train the model, and see on this data that we have set aside, which we call a validation data, we see which combination of parameters is working the best. And then with the assumption that the real data will also have similar distribution, we stick to those parameters. This is called hyperparameter tuning, and this in itself is a big topic with various methods available for that, starting from some basic grid search like algorithms where you try every possible combinations, to some advanced methods like Bayesian hyperparameter optimization, where we sample the hyperparameters and then keep narrowing them using beam search or something like that. You can Google them and read up. For most basic applications, usually the grid search works fine if you have few parameters, but as it gets more complex, they require more complex methods for those. Okay, so masking has been answered before.
I think there is a question on self-attention. Probably, Arindam, you can take that.
Yes. So when transformers were introduced, the main innovation that they had about them was this thing called attention. So attention module is nothing but a set of manipulations of the input, which in some sense tells the transformer model which tokens or which words it should put more importance on and which it should ignore. So before transformers, what we used was RNNs or LSTMs, where it was a time thing. So at every time step, we used the entire previous context and we reduced the importance based on how far back the sentence, how far back in the sentence a word appeared. With that, what happened was that if there was some correlation between two words which are very far apart in a sentence, for example, you're somewhere using he, and that he was described very long back in the sentence, LSTMs were unable to figure out such stuff. Whereas with the self-attention, every word has access to this entire text, and the model itself decides where to put its attention on. Mathematically, the computation of self-attention is little involved. It involves splitting the input into key value pairs and then passing it through some sigmoid layer and then combining them using addition and normalization. The details you can always look it up in Google or something, but the main purpose is to make sure that the context is available to the model at all times.
Thanks, Arindam. I think there was a question on supervised and unsupervised. I've answered it on chat. And then we have a question on SimClear, the basic basic working of SimClear, right? So I think as discussed in the lecture, SimClear is a self-supervised contrastive learning methodology for image representation learning, right? So what the basic idea about it is, given an image, if you are distorting the image or applying some augmentations to the image, like cropping or changing the color of it or something, still the semantic meaning of the image will be same, right? I think the paper talks about dog image as an example, right? It's the same dog. If you flip it or if you rotate it or if you change the color of the pixels or something, still the shape aspect of it and the texture aspect of it stays intact, right? So these two images, a raw image and a distorted image, are supposed to have a similar embedding, or they're supposed to stay closer to each other, right, in the embedding space. And the entire loss function is about this particular aspect, right? Given two images, the image and its distorted version should be closer, and the image and any other image within the batch, right, which does not represent a dog or any other forms of dog, they should lie farther apart, right? So they achieve this basis the softmax based similarity between the two vectors, right? So it is similar to what you have seen throughout the lecture, the softmax based similarity approach, right? It is just the way you create your positives and the negatives in it, right? For which pairs of vectors you need this embeddings to be closer, and which pairs of vectors you need the embeddings to be far apart. So usually we define that as a positive and a negative. For the positives, we need them to be closer, and for the negative samples, we need them to be farther apart. The same concept is being explored in Simpler paper. So this is a brief understanding about the paper, but I think more details, I think you have to refer to the paper to understand it, but it's a very good read. I would suggest you to go ahead with the paper reading.
All right, thanks, Vishnu. Next couple of questions I've answered in the chat. One is about creating LLMs by self. It is computationally prohibitive, but you can, and you can refer to the link I've shared to decide when to do that. Next is going through mathematical aspects in deep learning essential for a job role in ML. I'd say yes. While many would say it's not technically a strict necessity, but it's always good to learn. As long as you're using off-the-shelf algorithms, you might get by without knowing the maths very well. But the moment you're trying to work on something new, the math could help you a lot. So I'd say you should invest in it a little bit. So next is when should I use deep work? What is the purpose of it? So deep work is just like, so you're familiar with word2vec, right? Word2vec, what it does is in an unsupervised fashion, it generates representation for one word given the context. The same with deep work. So deep work, the name comes from something similar in the past called random walk. It was the kind of algorithm that Google and all uses to get the context of a web page from the web page that it links to. So deep work also takes such a graph, and depending on what other nodes that particular node is connected, it creates a representation for that particular node. So based on who your friends are, it will create an embedding of you in a social network, or based on what pages are linked to you or you link to, will create a representation of you as a web page. Okay, hope that answers the question. Next one is answered in chat. Next is how do researchers train complex architectures like ResNet, SRG, and Stable Diffusion and achieve better results? Because changing neural networks may give better result. Is the solution for this a hyperparameter tuning, or is there any other procedure to optimize the network? So there is a huge body of research that tries to do this, right? So we don't usually arrive at, let's say, a stable diffusion architecture just by trial and error. So yes, there are some ways to arrive at some optimal algorithms, but more often than not, it is mainly, so couple of things. One, it's not always possible to optimize the network. So of course, it is possible that there is a better network architecture available that we have not discovered it, purely because it's not possible to either mathematically prove that one architecture is the best architecture, or it is not computationally feasible these days with such huge models to try many different architectures. But the way we usually arrive at some reasonable architecture and model is to try it. First, it has to have some rationale behind it. Like we knew LSTMs introduced this forgetting get because RNNs had some problem about gradient diminishing kind of issues. So you have to either be solving one particular problem that the older architecture have, and second, with smaller models, you have to show your proof of concept that these changes are actually what is contributing to new, better performances. right? And of course, then it's always some peer-reviewed paper, journal that you're publishing this stuff in, and they would either then iteratively improve your model and come up with better models. Yeah, there is no one such technique to achieve a best model, is what I was trying to say.
I think next question is on autoencoders. I've answered that in the chart. So we can move forward to the following one. So in recommendation system models, how to choose the best algorithms in terms of either supervised or unsupervised, right? Based on efficiency. So basically, it is not related to efficiency. I think it is based on whether you have labeled data or unlabeled data, while you can still benchmark the unsupervised model and the supervised model on efficiency. Usually it is preferred. Let's say you have a large data which is labeled. I think the preferred choice is to go for supervised learning. And irrespective of either it's a recommendation system or any other task, right? This is the preferred criteria for choosing between these two algorithms, right? Arindam, just correct me if I'm wrong. Is there any other specific details on recommendation systems?
No, I think that about covers it all.
Okay.
So the next question is approximately how much data do we require to make our own LLMs? Yes, data is the most crucial things, and also process to training and deploying an LLM. So funnily enough, previous machine learning algorithms did not have any well-studied results about how much data we need, but for LLMs we do. I'll try to link the paper which does that study, but we have found that for a certain amount of certain model architecture, there is an optimal amount of data that we need, and people at Microsoft Research has done some work on it to come up with that. As for the second part of the question, I don't think we can answer that in this particular forum, but there are many tutorials available in the internet to, not to train from scratch, because like I answered before, it's often very infeasible. You require loads of GPUs and all. Maybe a small model you can just try for your training purpose, and then you can deploy it. There are many blog posts which explains how you can do that. There are very NVIDIA specific libraries such as Triton and ONNX, which helps fast deployment of LLMs for real-time usage.
Yeah, I think the next question is from Shivansh. It's about using Sellout Analysis for clustering, or can we use that tool for cluster analysis, right? Yes, Shivansh, I think you can use that. So basically for k-means, one of the main parameters, the k parameter, right? There is a method called elbow which uses a comprehensive exhaustive method wherein you select the k's each time and see when the curve reaches the elbow to select the k. One other method is a sellout method, right? Like wherein you analyze how each point in the data distribution is closer to the cluster centroid, right? And this can be viewed by the Sellout algorithm, as well as getting the plot of the Sellout, which gives a analysis on the separation between the points and the cluster centroids, right? So it is one other tool wherein you can analyze your clustering result post your convergence. So the next question is about GNNs or CNN, which is best and as efficient. So it is not easy to say like that. So it depends on the problem, right? So neural network is applied for graph structured data, right? While CNNs are de facto standard for image-based data, right? while the concepts of convolution is also used for GNNs, there's something called graph convolution network, wherein the concept of the convolution, right, the filter-based calculations of nearby neighborhood features is also applicable within the graph structure, except that instead of pixels, now you have nodes of graphs, right? So depends on the problem statement, it depends on the input data, right? There is no specific details on, criteria or understanding about which is efficient and which is not, right? So I think that should be that. And
the next question is about how to learn ML, because they're claiming that projects usually require you to learn the whole thing before you can move ahead. So I would suggest that I think Vishnu has pointed out some books, not in this, I think, in previous. Yeah, you can. There are some textbooks that has some good exercises. You can try them. Hands-on approach is always better for machine learning, and you can find various very entry-level projects which you can take up to learn your ML concepts. But yes, when you're just starting out, just take a toy data set and apply the one particular algorithm that you are working with. That should.
So I've pasted the links to the books in the chat window. Maybe everyone, if needed, you can just make a note of it. So the next question is about how to deal with important outliers within the clustering algorithms, right? Yeah, this is a good question. So clustering algorithms, the ones which we discussed in the lecture, right, the k-means and all, they are quite sensitive to the outliers in the data set, right? Your cluster centroids or the cluster formation can be skewed with the presence of outliers. So there are methods which are insensitive or robust to such outliers. So I would request you to look into those methods which are based on density and probabilistic modeling methods, right? We have density-based and distribution-based clustering, which we did not discuss in detail, but there are few methods out there which usually handles such a scenario, right? DB-scan is something which you can refer to, wherein it deals with both noisy data, which is outlier with the presence of outliers, as well as it can work on non-convex space and not expecting spherical distributions. So I'm just writing the details of those particular methods here.
Right. So for detecting fake gateway transactions or fake bill pay transactions, what learning strategies can be implemented? So this is a good question. So first, these are kind of anomaly detection problems. So you can apply any of your anomaly detection algorithms that you have learned. Another thing that is important to note in these kind of applications is that you may not have a good collection of negative samples. For example, you will not have many fake transaction examples in your data set, whereas good transactions you can get in millions. So for such, there are various imbalanced learning techniques that you can apply to improve the performance of these existing anomaly detection models. Okay, so good course recommendations. I think the textbooks that Vishnu has shared are good starting points, and then for me personally, reading the papers and working through the blog posts work best. But if you are looking for some video courses, then all the resources, like Coursera has some good resources. Even YouTube itself has some pretty good resources. I do not have any particular ones in mind, but yeah, the ones that you pointed. They're all good, but there are so much data, so you have to be wise in picking which one you want to work on. Yeah, anything to add there, Vishnu?
No, I think that's right. So basically, Coursera courses and all, they have professors explaining you the topics, as well as you have a detailed examination or an assessment, right? So that is also a good way wherein you also get an achievement or some sort of a certificate at the end of it. However, there is also like very master level or postgraduate level courses wherein they open source their lectures, right? Like from Stanford or other universities, right? These are also very, very good lectures. It goes in details of the foundational as well as the mathematical aspect of it, right? And as you all know, there's also NPTEL videos, right? This is also some of the lectures are very, very good, and it talks about basics as well as the state-of-the-art methods. So it's not like one course which will give you the entire knowledge about it. Usually books would give that, but when you prefer courses, it is usually a multitude of things, right? So you pick the right and try to figure out, depending on your skill set, which one, and also your pace in learning, which one would be more suitable, right? So these will be the most ideal ones to get started with, at least.
Okay, so the next question is for gesture tracking. Can similar hand gestures be clustered accordingly, or there'll be a problem because they're images and not points? No. So them being images and not points are definitely not a problem, because all these representation models like SimCLR that we have talked about, or any representation learning, what they do is they take this image and then map them to a point. And once you have that point, as long as the embedding is good, you can go ahead and apply any of your clustering algorithms to make sure that you're clustering similar hand gestures together and then process them as you like.
Yeah, see, the next question is already answered via chat. So we're picking the follow-up one. So I'm working on this deepfake detection models and generative models, and about the recent trends and GANs, and which GAN should be preferred to be used and how to choose it, right? Yeah, this is a broad question. So it depends on the more specific details about your application, right? So usually generative models are conditional GANs, right? You want to generate a specific style or a specific a pattern of what you want to generate in your distribution. So it depends on the type of the conditions which you want to use. And I think, as you rightly said, there are multiple GAN architectures, right? As even we discussed part of this, there's DC GAN, cycle GAN, disco GAN, and multiple other things. So it's better to take the survey papers, especially that from the trends, right, and see the pros and cons of each one of them, and try to identify what is very, very important in your application, right? And then go ahead with, let's say, a few of them in your experimentation. So this will be one preferred choice of usually choosing the model, trying to understand your problem statement in detail, what are the challenges and limitations in your data set and your problem statement, and what is available in the literature, the state-of-the-art methods from the recent papers or the surveys, right? And trying to figure out which one would match and which is more feasible with respect to implementation, as well as the data and the training capacity of it.
Right. So the final question is how to get a job into ML domain just after college as a fresher. I don't know. Apply for the job, I guess. No, so all kidding aside, so basically you just have to build your foundations well, right? The pace at which the field is moving right now, it's not possible for you to stay abreast the most recent technologies and stuff. So I suggest you don't bother about those stuff too much, but make sure that you have good breadth about the foundational topics as well as depth on some specific topics. That should help you get started, I assume. Vishnu, you can add anything to it.
Yeah, so yeah, sometimes it feels like as a fresher, right? Like maybe with a bachelor degree or something, the field maybe looks quite overwhelming, right? Looking at the math concepts or the way, the pace at which the community is moving, right? But this is not, let's say, a hard requirement or a bottleneck for you to getting into ML topic, right? So even within our teams, we have several freshers as well as some who have done internships, and with the internship, you're gaining quite a knowledge, right? So as you get into a particular project or a particular research topic, the level of expertise you will gain in that topic, I think you'll be equal to anyone within the same domain, right? Because you are working very, very close in that particular topic, and you know the the deep or the pits and falls of that particular problem statement, right? So it is, as Arinam said, both the depth as well as the breadth. So as you start working on multiple projects, your breadth of the machine learning domain will increase, and as you're working on each of the individual project, like each of the problem space statements or the domains will have its own intricate details, right? And your depth also would increase. So it is it might look a bit difficult, but it is not a very, very frightening or how you are thinking, right? It's a straightforward approach. Just as Arindam said, right, just apply for the job and understand the requirements of the job, right? Probably you can freshen up your concepts on those particular details, right? Every job will not be like about everything in ML, right? It will be very specific about a particular role, dealing with time series data and all, right? Or in image domain. So you can pick those particular domains and try to have the breadth and the depth of the domain, so which will give more prospects about the job itself. So the next question is about, can we integrate ML strategies in such a way that they can act as a security for client websites? Yeah, I think, of course, ML is applied everywhere, right? Like every place where you're detecting a fraud, right, or detecting an abuse as a security shield, right? It is applicable. So all it demands is just some huge amount of data where the representations of good cases as well as bad cases, fraudulent behavior and non-fraudulent behavior, all these things are represented in the data set. I think you can learn a good system using machine learning algorithms, which can predict or detect, let's say, any threat of fraud in incoming traffic, right? So it's a more broad answer, but I feel that would have answered your question.
Sure. So the next question is, ML is full of problems applying to many ML courses. We are just getting idea about the theoretical concepts. How should we learn about the problems and practical knowledge on ML? Yes, so of course, to get started, you need to know some basic concepts. But once you have acquired them, there are many ways to get into the practical world. First is you can take some small data set and then start exploring it, start applying the algorithms that you know. Once you are familiar with the applications and stuff, then there are platforms such as Kaggle where you can go and pick up any problem in any domain that you like. You solve it, come up with some algorithm, submit it, and see how well you are doing compared to others. Look at other people's solutions, because there is some gap, right, on what you learned in theory, where you are expecting all pristine data set and everything, you just run the algorithms. Whereas in practical application, you'll see that cleaning the data and that kind of stuff has a big role to be played. So yeah, just look at other people's solutions, try to solve your own problems and put them in the leaderboard and see how well you're doing. And once you're familiar with that, then there are innumerable challenges available. Like Google comes up with one challenge every year, and Kaggle has their own competitions and stuff which you can participate in. So there are many ways to take that on. Alright, so the next question is this preferable to do MTech or MS in machine learning? I'm not very familiar with the difference.
Yeah, so I think it depends on the course details, right? So right now we wouldn't be in a position to answer that. So we request you to probably reach out to your educational counselors or someone who is studying in this particular course, right, to understand the more details about it. But not really sure about the difference between the MTech and MS here. But any higher studies on this topic would definitely be helpful, and we would also encourage you to proceed further if you find very much interesting in these courses.
All right. So next is how to improve ML model to train dynamically. So they're getting feedback from mobile and using that statistics to improve the model. So it depends. There are many ways to do that. One very obvious way is to retrain your model. Whatever new data that you're getting from the feedback, you can use it as a new data and then train a model. Another way would be to use that as a reward of some sort and then use it in reinforcement learning settings. So your model will tweak to try to get more of such feedbacks which are more favorable to the user and try to avoid those which users don't like. Those two are methods that come to my mind.
Yeah, there is also something called active learning. I think you can refer those literature, which exactly deals with the problem or the statement which you are mentioning here, right? In addition to what Arindam has mentioned, right? Active learning and then on-demand reinforcement learning, those things should be some of the methods which you can refer to.
All right. So next question is, with the robots coming, will it be challenging for humans to compete? I'd say this is out of the scope of this. We can have very long discussions about this, both technically and politically. And there are no good concerns. Of course, there are some threats to some kind of work, but it's not as cut and dry to say that yes, robots will take all our jobs and stuff. So yeah, it's a complicated question. Okay. Right, so we have answered all of the questions and we are also almost out of time. So there are a couple of minutes if anyone wants to ask something. In terms of job opportunities, Amazon or any other top master's degree in machine learning from top tier university provide edge over other applicants. It's hard for me to answer. I would imagine yes, it would give you some edge, but I am not sure if that would be the only deciding factor. Vishnu, do you have an opinion?
Yeah, so of course, a master degree or any further degrees will help you understanding ML as well as broaden your skill set, right? This is one criteria. But however, this is not the only requirement to get into the field or get into Amazon or apply for our job roles, right? We do respect every background and every skill set, right? If the job fits the skill set what you possess right now, and you see a good growing as well as learning capability within the job role, I think Amazon would prefer such a candidate, right? And so I don't think there is a hard requirement about it, but yeah, any degree or any further studies will anyways be helpful to your skill set, right? Either you acquire it via formal education or via other means, right? Given the scenario right now in terms of Kaggle competitions or other ways of acquiring knowledge, right? I think we respect every such cases. So all of them would be equally treated, but more specifics I think will depend on the job role and how the skill set matches with the expectations of the candidate as well as the employer. Yeah. Okay, so I think we are close to the end of the session. Yes, regarding the recordings, I think probably you can reach out to the organizers with the emails, and you will probably be getting the recordings once all the sessions are over. And yeah, I think there's another question on convergence, but I think we've discussed this, right? Like there's no specific need for, there's no benchmarking on such methods of which converges faster. Of course, individual methods I've checked that, I've analyzed them, but let's say this should not be one of the main criteria for selecting an algorithm, right? Like it depends on your initial conditions. Convergence might get faster or slower depending on initial convergence, but it depends on how robust your method is with respect to handling outliers or how it fits well to your problem statement, right? While convergence is also something to look about, but all these recent methods, they have a proven convergence rate, right? And can converge at a specified iterations. So for more details on which converges faster or not, probably we request you to refer such survey papers, right, which compares those architectures or the methods very detailed on the convergence as well aspects. Okay, thank you everyone for joining the session. I hope we answered everything and was very useful. Please also join for the next sessions, right, following next week. Thanks.
Thanks, everyone. Bye.
Thank you. Bye bye.